Hello, Mr. Mailer here, your online math teacher, and welcome to my channel. Today we're going to be talking about the distance formula, which you might not realize is directly related to what I would consider right triangle trigonometry. So let's get into this. So today our goal is to be able to find the distance between 2 points in the plane. By that I mean xy plane. So the real important thing here is knowing what that formula is. So if I have 2 points, x1, y1 is the first point, and x2, y2 is the second point, the distance formula is going to be the difference of the x coordinate squared added to the difference between the y coordinate squared. Then I take the square root of the whole thing. So you might not realize that, but I like making this note. This is where it's related to right triangle trig, and that this is a direct result of the Pythagorean theorem. So if I'm living in a plane, and if I give any 2 points here, you can actually form a right triangle between them. You should always be able to do this no matter what 2 points you get, unless they are on a horizontal or vertical line. So they are literally on the same line with each other, horizontal or vertical, and then you can just count the number of units, so take the difference, find it. But when they're not on the same horizontal and vertical line, we can make this right triangle, and we can notice that the vertical leg, this is just us looking at y2 minus y1, so, or the magnitude of it, and this x leg is just looking at the magnitude of x2 minus x1. So that means that our distance in this case is the hypotenuse, so we can just take these differences and square them to get our leg lengths, square the hypotenuse to get the distance squared, and that's where we see the Pythagorean theorem. So this is really just Pythagorean theorem solved for distance. So now we want to look at how we can solve an actual example with this. So I have 2 points here, 5, 3, and negative 4, 6. So the first thing I need to do is plug into my formula. And for this, I'm going to let at my point 5, 3 play the role of x1, y1. And I'm going to let the point negative 4, 6 play the role of x2, y2, and there's really nothing special about picking which pair is which. The one thing you do probably want to make sure for good practice is pair your ones with your ones and twos with twos, like I did here. So now, if I want to know the distance between these points, I'm going to start plugging into my formula. So I have x2 is negative 4 here, x1 is 5, so I'll put that in there. So negative 4 minus 5 all squared, plus y2 is 6, minus y1 is 3. I'm going to square that. So now I'll start to simplify what I have inside my square root. So negative 4 minus 5 gives us negative 9. I'm going to keep that inside a set of parentheses so I don't forget that that negative has to get squared as well. This is a common mistake that will happen if you don't use parentheses. So, and then 6 minus 3 is just going to give me 3. So again, I'm going to put that in parentheses just to keep good practice. So now all I need to look at is negative 9 squared, which is going to be 81, and 3 squared is 9. So that brings me to that this answer is the square root of 90. Now, I typically ask my students to put these questions in simplified radical form. So we want to make sure we know how to simplify this or check if it can be. So I'd always recommend make a factor tree if you don't immediately know how it's going to simplify. So I can do that over here. I'll take my 90, look at it. I know 10 goes into that. So I'll start by pulling out a 10. So I have a 10 here, a 9 here. I know that 10 can be broken down into 5 and 2, neither of which can be broken down anymore. And 9 can be broken into 3 and 3. Then since it's a square root, I'm looking for pairs. I have a pair of 3's here, so that means that if I want to simplify my square root of 90, a 3 can come out front to replace that pair because it was a pair of 3's. And the 5 and 2, each of them doesn't have anything to compare with, so they have to stay inside of my square root. So I have my 5 and my 2 stuck inside there still, which means that this is really just 3 times the square root of 10. So that is my simplified distance and radical form between these 2 points. And that's really all there is to the distance formula. I hope you found this video helpful. Like and subscribe, and I'll see you again.